Hello everyone and welcome to our new section which is called Queue. With this lecture, we begin a brand new section in which you will learn everything about queues. In this section, you will get a deep knowledge about queues, which includes creating queues based on Python list and linked list and performing various operations like creation of queue, enqueuing, dequeuing, picking, and deleting operations on these queues. In the first lecture, let's see what's a queue. So let's get started. By definition, a queue is a data structure that stores items in a first in, first out manner. So what does it mean? So let's see it in a real life example. As you would have guessed, the queue is the same as the real life queue that we see in our daily lives. So here we see that a bunch of people formed a queue to buy a new iPhone from Apple Store. So the queue data structure is also very similar to the queue that we see over here. So now let's closely observe the common feature of this queue over here. The first feature is that if someone wants to buy a new iPhone, he or she has to stay end of queue over here. So it's obvious that he cannot join the queue from the beginning or from the middle of the queue. He has to join the queue at the end of queue. This means that a new addition to this queue happens at the end of the queue. So the next feature is that a person who is at the beginning of the queue will buy iPhone first. So this means that she will be served first. Then second person will get the iPhone, then the third person will get the iPhone, then the fourth, and it continues like this until the end. So if we summarize these features over here, we see that we are following FIFO method over here, which means that first in, first out. So in this queue, this lady over here came first and she will get the iPhone first as soon as the store opens. Then the second, then the third, and it continues like this till the end. Now if we compare this behavior of real life queue with the queue data structure, we see that in queue data structure we follow FIFO method. So that means that whichever element comes to the queue first goes out first. So let's say we have a queue like this. So if we want to insert 40 to this queue over here, we have to insert it at the end of queue over here. So if we want to insert the next element over here, we have to insert it at the end of queue again. We cannot insert it anywhere between these elements over here. And when we want to take an element from the queue, the only option is to remove it from the beginning of the queue over here. As you see, we have mentioned that this is the front of the queue, so we have to remove the element from the beginning of the queue. Now if we continue to take out second element, we have to again take the first element from here. Then, if we try to take one element from over here until we reach the end, it will go like this. So hopefully you have understood the concept of the queue. Now let's see why do we need queue data structure. So in case when you need to create an application which utilize first coming data first, then we need to use queue data structure. And when we want to implement FIFO method in our application, we have to use queue data structure. As the name suggests, queue is used whenever we need to manage a group of objects in which the first one coming also gets out first, while the others waiting for their turn. So let's see the applications in which we are using queue data structure. The first application is point of sale system of a restaurant. It's obvious that the orders must be processed in the order they were received. As an order is received, it rises to the back of the queue and reads order from the front of the queue by cook's device. This allows cooks to cook meals in order they received. Now the second application can be a single shared printer. So whenever many people want to print the document from this printer over here, who sent the document to the printer first will be printed out, and the other documents will stay in the queue as soon as the first one finished. And the next application that we are using queue data structure is call center application. So it's obvious that when a new call comes, it stays in the queue as soon as new call center agent becomes available. Then this call will be served, then this call and this call. It will continue like this. And others will stay in the queue as soon as the call center agent finish his previous call. Now with this, we have completed this lecture. So in this lecture, we have learned what's the queue data structures and why do we need it. So hopefully everything is clear here. Now in the next lecture, let's see standard queue operations.